Today we're going to be working with absolute value inequalities. So your essential question is, how can you solve an absolute value inequality? So we're just going to do some examples of this, but we're going to kind of list out the steps as we go. So it says solve each inequality, graph the solution if possible. So right now I have the absolute value of x plus 7 is less than or equal to 2. Okay, so remember, when I talk about absolute value, we got to think about what the absolute value definition is. So absolute value is how many spaces a number is from 0 on the number line. So if I'm trying to make it less than or equal to 2, then what two numbers have an absolute value of 2? Well, we have -2 and we have +2, are both 2 spaces away from 0. So first, what we're going to do, since this is an inequality, is we're going to write a compound inequality. Okay, so to write a compound inequality, that means we're going to have our solutions between -2 and +2. So we're going to have -2, which is less than or equal to x plus 7, which is less than or equal to 2. So from here, we're just solving this compound inequality just like we did before in the last section. So if I'm trying to get x by itself, I'm going to subtract 7 from both sides, all the sides. So these cancel out, and -2 minus 7 would be -9 is less than or equal to x, which is less than or equal to 2 minus 7, which is -5. So I should be able to graph this on a number line. I have -9 and -5. And it says equal to on both, so they're going to be closed circles. And then it's supposed to be, x is supposed to be less than -5, but greater than -9, so it's going to be in between these two. That means that if I plug in any number between -9 and -5, or I can plug in those numbers also because it's equal to, then it should work for x. So let's just pick a number between -9 and -5 and plug it in for x to check our answer. So let's say I pick -7. Okay, so I have the absolute value of I'll write this over here. -7 plus 7 is less than or equal to 2. Well, -7 plus 7 is 0. So I have the absolute value of 0 is less than or equal to 2, and 0 is less than or equal to 2. So that is a solution. So if we want to list out our steps, the first step was to write a compound inequality. And then the second thing we did was solve for x. So number 2, if you want to write these down, was solve for x. And then number 3 was graph and check the solution. Okay. So let's try this other example over here. All right, so we have 8x minus 11. The absolute value of 8x minus 11 is less than 0. Okay, so before, when we set this up, we had to think about what two numbers had an absolute value of 2. Well, in here, if we're thinking of what has an absolute value of 0, it would just be 0. There's only one number. But this also says less than 0. Okay, so what numbers have an absolute value of less than 0? So when I take the absolute value of a number, does it come out to be negative, 0, or positive? It comes out to be 0 and positive. So I have to have 0 as an answer or a positive number as an answer. It's impossible to get an absolute value of something that is less than 0. So this one actually has no solution. Okay, and that's because absolute value cannot be less than 0. All right, let's try some more practice problems. So we have the absolute value of c minus 1 is greater than or equal to 5. So first I need to write my compound inequality. Now, which two numbers have an absolute value of 5? We have negative 5 and positive 5. So we have negative 5 is greater than or equal to c minus 1, which is greater than or equal to 5. So the absolute value of this has to be between negative 5 and positive 5, or equal to one of those numbers, in order for this to work. So we're going to solve for c. So we're going to add 1 to all three parts. So negative 5 plus 1 would be negative 4 is greater than or equal to c, which is greater than or equal to 5 plus 1, which is 6. So if I graph this on a number line, then I have negative 4 and positive 6. And they're both equal to, so they're going to be closed circles, because that means I could plug in those numbers if I wanted to. And then it says c is greater than 6, so actually that's going to go this way. And c is less than negative 4, so that's going to go this way. So actually this time my graph points apart. So they don't always connect. You really need to pay attention to your symbols and see how this turns out. Now we can check our solution, because if I plug in a number greater than or equal to 6, it should work. And if I plug in a number less than or equal to negative 4, it should work. If you plug in a number in between, it will not work. So let's try that. Let's pick a number between negative 4 and positive 6. So let's pick, let's see, we'll pick 2. So we have the absolute value of 2 minus 1 is greater than or equal to 5. 2 minus 1 is just 1. And the absolute value of 1 is 1, and 1 is not greater than or equal to 5. So we know that they should point away from each other and not connect. Okay, letter B. The absolute value of 10 minus m is greater than or equal to negative 2. So let's think about that. The absolute value of something is greater than or equal to negative 2. Well, we have a negative number over here. Okay? If I take the absolute value of negative 25, I would get positive 25. If I take the absolute value of 0, I get 0. If I take the absolute value of positive 99, I get 99. All of those numbers are always greater than or equal to negative 2. So no matter what number I plug in for m, I'm always going to get an answer that's greater than or equal to negative 2. So this one is infinite solutions. Now before we go on, let's back up and look at the difference between the problem that had an answer of no solution and this problem that has an answer of infinite solutions. Okay, so if we back up to that last slide, this one says less than or equal to 0. Or I'm just less than 0, not less than or equal to. So if it has less than 0, then it's going to be no solution, because nothing has an absolute value less than 0. But this one has greater than or equal to a negative number. So more than likely, if it says greater than a negative number, then it's going to be infinite solutions, because that will always be possible. And if it says less than 0 or less than a negative number, then it's going to be no solution, because that's not possible to get an absolute value of less than 0. All right, let's look at this very last example. Now this one, we have a lot of extra numbers around the outside of the absolute value symbol, so we need to make sure that we get rid of all of those first. So we always add or subtract before we multiply or divide when we're solving equations and inequalities. So we're going to first cancel out the 1 by subtracting. So then we have 4 times the absolute value of 2x minus 5 is greater than 20. And then to cancel out the 4 is multiplied by the absolute value, so we need to divide by 4. Now remember, these are not parentheses, so we do not distribute when you see a number in front of those. Those are absolute value symbols. They're very different. So we have the absolute value of 2x minus 5 is greater than 5. Okay, so now we're down to a regular absolute value inequality, just like the other examples that we've done. So we need to go back through our steps. First, we need to write a compound inequality. So what numbers have an absolute value of 5? Well, we have negative 5, and we have positive 5. Oops, I didn't need to write those. Once we do this part, we don't need to write our absolute value symbols anymore. So we're going to solve this. So we need to cancel out the 5. So we get 0 is greater than 2x, which is greater than 10. And then we need to divide by 2 to cancel out the 2 and get x by itself. So these go away, and we have 0 is greater than x, which is greater than 5. So we're going to graph this on a number line. And so it says x is greater than 5. So this is going to be an open circle, and it's going to point to the right. Those are all the numbers greater than 5. But x is less than 0. So it's going to be open and point to the left. Now remember, if you're not sure if it's supposed to point away or together, then you can check a point. So we're going to check a point. So if we check a point in the middle of 0 and 5, let's try 1. So let's say that we go back to the beginning, and we have 4 times the absolute value of 2 times 1 minus 5 plus 1 is greater than 21. So if we work out the part inside the absolute value symbols, 2 times 1 is 2. 2 minus 5 is negative 3. Plus 1 is greater than 21. The absolute value of negative 3 is positive 3. So 4 times positive 3 would be 12. Plus 1 is greater than 21. So I get 13 is greater than 21, which is not true. So because that is not true, then I know that my graph can't connect. It has to point away from each other. So if I plug in a number less than 0, it will work. And if I plug in a number greater than 5, it will work. Now, one more thing before we're finished. Let's talk about the graphs for a problem that has no solution and a problem that has infinite solutions. So for this problem here in the middle, if it has infinite solutions on a number line, that means that I can plug in any number I want. So on my number line, let's say here's 0, 1, 2, 3, negative 1, and so on. My graph is going to cover all of this because I can plug in any number on the number line and it will work. Now if I back up to the one that had no solution, then if it has no solution, then I can't graph anything on the number line. So this one you will just not graph. But for infinite solutions or all real numbers, you will draw a line over your number line to represent that it will be any number or a solution. All right, please make sure that you guys go back and answer the essential question to write your summary and write your 2 potential test questions.